All right, good day. Hope that you're doing well. So in this video, we're going to be doing the last question from the 2023 November question paper, and we are still on Euclidean geometry. Now, to be specific, we're going to be doing question 11. Now, question 11 is saying that DE is a tangent to the largest circle. Now, let me highlight my DE line. Now, DE is the tangent to the largest circle, right? And every time whenever I have a tangent, I always think of tan-chord theorem, as I've said before in the previous videos. Now, this is the angle between your tangent and your chord. It will be equals to this angle here, which is your inside your triangle. So if I were to draw that Z shape, note that E1 is going to be equals to F1, right? So this is the first point that I could write before I go about answering any question, right? It's going to be equals, before I forget, also F1 and tan chord. I'm going to make note of that here, right? Now also, okay, now DH is a tangent to the smaller circle. Now let me see if I could identify the same angle here. So this is my chord, or my tangent rather. And if I were to apply the tan chord theorem drawing the Z shape, in this instance, my H1 is going to be equals to G2, right? So H1 is equals to G2 tan chord. All right, so now that is what I wanted to draw out. So let me just erase here now that I found these angles and I know that these two lines are my tangents. Now, let me see what is it that the question is asking for me, right? So now, obviously, these information that we're given here is the explanation of the sketch, but the main point that I wanted to show you is that every time whenever you were told that something is a tangent, try to think of your tangent theorems, right? And try to see those angles that are equal based on your tangent theorems, to be specific, theorem 8, 9, and 10. Now, complete the following. D3 is equals to plus exterior angle of a triangle. Now, let me highlight my D3. So this is where my D3 is situated. And remember, with regards to exterior angle, if I were to draw this, remember, your exterior angle is equals to two opposite interior angle of a triangle. This, it will be equals to this plus that, right? So the addition of these two, they're going to be equals to exterior angle. Now, D3 is the exterior angle to which triangle? If you know, D3 is the exterior angle of the big triangle. What triangle is that? So basically, triangle DEH, right? So, and this is my D3, because why? This exterior angle extends up until my line DE, right? So it's a exterior angle of this big triangle. As a result, it's going to be equal to the addition of these two angles, H1 plus E1. So here it's going to be plus angle E1. All right, now that will be for the first question. Now let me just erase here so that I could answer the second preceding question. Right, now every time in these kind of questions, try to use whatever that you've calculated before. Now, when you have an Euclidean geometry question which doesn't have values, always try to make use of what you've calculated before. Right, so now let's see what the next question is requiring from us. Now, prove that DEFH is a cyclic quad. Now let me highlight the shape that they want me to prove that it's a cyclic quad. So now, remember, there are three ways of proving that something is a cyclic quad, and I'm going to write it right over here on the sides, right? So the first way is that if you could prove that opposite angles are supplementary in that shape. So let me refer to this as H, this is D, this is E, this is G. If you could prove that any opposite angles, they add up to 180, therefore this shape is going to be a cyclic quad. This is the first way. Now, the second way is that if you could prove that, so let me just try and make a sketch here. It's basically your exterior angle, right? Now, if I look at my exterior angle here, the exterior angle that I have is here. So this is my point H, and my exterior angle is H4 and H2. Basically, my exterior angle is H4 and H3. If I could prove that this exterior angle is equal to the opposite interior angle, which is angle E, remember your E is divided into two, E2 as well as E1. If I could prove that this exterior angle is equal to the opposite interior angle, therefore this whole diagram would be a cyclic quad. And remember, here I have point F, and at the top it's supposed to be point D. This is another way. And lastly, this is if you have something like this kind of a shape. So, right. So basically, let me name these points D, F, E. If you could prove that this angle is equals to that angle, therefore HDFE is going to be a cyclic quad. All right. So now let me see which of these angles can I use. Now, I'm not going to use the first one. Why? Because I don't have values. right? So it will be difficult for me to try to prove that two angles opposite to one another, they're going to be supplementary when I don't have values inside my shapes or on my shapes, right? So let me see if I could prove the second one. Basically, if I could prove that H4 as well as H3, they're going to be equals to E1 as well as E2, right? So now, making use of the information that I have. And also here, as I'm looking from the diagram, I could see that I have another line extended here, which is D3, meaning that another way I could try to do this is prove that D3, it will be equals to the whole of F, which is F1 as well as F2. So there are two ways. It's either I could use H and E, or I could use D and F, right? And depending on the information that I have, or rather based on what I've calculated before, I've made use of D3 before, right? So for me, it would be a good idea to start with D3, basically proving that this D3 is going to be equals to my F1 as well as F2. Because why? Before I had calculations relating to D3. Now, remember, I'm trying to prove basically here, I'm trying to prove that D3 is going to be equals to the whole of angle F, right? Basically, let me write it here on the side. I'm trying to prove that D3 is going to be equals to F1 plus F2, all right? Now, let me start making use of the information that I calculated before. Now, remember D3 is equals to H1 as well as E1, meaning that if I could prove that F1 or F2 is equals to both of these values, right? Therefore, I would have proved that my D3 is equals to whole of angle F, right? So now, let's see. E1, remember before, I said that your E1 is going to be equals to F1. Basically, why tan chord theorem. So this point, I'm going to make use of it here. E1, this is equals to F1 and tan chord theorem, right? So now here, I've proved that E1 is equals to F1. So here, I could just substitute F1. Now I'm left with proving that, right? So can you see that here? I'm left with proving that H1 would be equals to F2. Now, if I could prove that H1 would be equals to F2, can you see that now my whole of D3 is going to be equals to F1 plus F2, right? Now, let me see how I can interlink the two, H1 as well as F2. Now, let me highlight them here. This is my F2 and this is my H1. Now, H1 is it's an angle between a tangent as well as a chord. Now, let me see if I could also use my tan chord theorem here. Remember the Z shape, right? Right. Now, can you see that these are going to be equal to one another? Right. Remember, this is like that. The Z shape has to be like that. Now, can you see in accordance to tan chord, H1 is going to be equals to F2, right? So this would be my another point, right? So I'm going to say, okay, H1 is equals to F2, tan chord theorem also, right? So as a result, this H1 is equals to F2. Now, can you see that now my D3 is going to be equals to F2 plus F1, which is my whole of angle F, right? Now, as a result, I've proved that this angle here, so let me try and erase everything here. Now, as a result, I've proved that this D3 is going to be equals to my F. Therefore, this whole thing is going to be a cyclic quad, right? So here I can say, okay, now in conclusion, my D3 is going to be equals to F1 plus F2. Now, why am I saying that? Remember, before I said D3, it's equals to H1 as well as E1, right? So this would make DEFH to be a cyclic quad. Right. And that will be all for this question, because remember we've proved that why this exterior angle is equals to our opposite interior angle, of which we need to write that reason here. And our reason is because exterior angle is equals to the opposite interior angle. Right. And this will be our reason. Now, let's move on to the next question, 11.3. Now, for the next question, we need to prove that DF, which is this line right over here. So if I were to highlight the line, this is our line DF. Right, we need to prove that this line DF bisects this angle here, F. Now, what do we mean by bisect? Bisect is cutting something into two equal halves. So basically here, we need to prove that this angle or this line DF is going to cut your angle F into two equal angles. Basically, F2 is going to be equal to angle F1, right? We need to prove that these two angles are equal. Now, I want you to note something. Remember before we said in accordance to the tan chord, right? So here, this point here, we said H1 is going to be equals to F2, right? And our reason was tan chord theorem, right? So this would be my first point. So if if H1 is equals to F2, and before we said this is tan chord theorem, can you agree that now if I could prove that this H1 is going to be equals to F1, therefore this angle F, it will be bisected, meaning that F1 is going to be equals to F2, right? So now I want to prove that H1 is also going to be equals to F1. Right. Now, how am I going to go about doing that? So let me see how I can interlink the two together. All right. So now remember, this highlighted in green is a cyclic quad, right? So it means that there is an imaginary circle here. So let me just try and draw the circle. My imaginary circle that with dot black lines, right? So now if this is my imaginary circle, it simply means that I can apply circle theorems here in this instance. Now, what do I mean by that? It simply means that, okay, now let's see how we can interlink these two angles to be equal to one another. Can you see that here they're basically going to be forming angles in the same segment, butterfly, right? Because as you could see, this is your butterfly shape that they form, right? This is the butterfly shape that they form. As a result, these two are going to be equal to one another, all right? So now I could say, all right, H1 is going to be equals to F1. And why is that? The reason being is that these are angles in the same segment. So every time whenever they ask you to prove that something is a cyclic quad, try to put the imaginary circle with dotted lines so that you could also apply circle theorems, right, to prove whatever angle that you want to prove. So as a result, because both of these angles are equals to H1, right, therefore your whole of angle F, it will be bisected, right? So now as a result, we can conclude that F1 is going to be equals to F2, right? Now we have proved that this line DF, it has bisected this angle F. All right, now let me erase here so that I could answer the preceding questions. Now, 11.4, if K1 is equals to E1, right? Meaning that this K1 is equals to E1, right? These two are going to be equal. Now, we need to prove that GK, right? So let me highlight my line GK. So this is GK. We need to prove that GK is going to be a tangent to the large circle, right? The large circle. So now, all right, let me go about trying to prove that. All right. So remember, there are three ways, right, of proving that a line is a tangent to a circle, right? So I'm going to try and write down the first two which are most applicable. Now, the first way of proving that a line is a tangent to a circle is if you have a circle and you have a line that passes through like that, right? Maybe let's say you're trying to prove, let's say this is our line GK, you're trying to prove that this is a tangent. So if you could prove that your radii, it would meet at 90 degrees with this line, therefore GK would be a tangent. This is one of the first ways, all right? Now, second way, it's your tan chord theorem. So basically, if I have a circle and I have a chord inside, this is my triangle, and you have this line here. So if you could prove that the angle between your tangent and a chord is equals to that, right? Tan chord, if you could prove that these two angles are equal, therefore this line GK is going to be a tangent. All right. Now the other one relates to if you have tangents from the same point. If these two, you can prove that they're equal, therefore they're going to be tangents. But in this instance, this won't be applicable, right? Now let me see which method can I go about choosing. It's between this one and that one. Now this one, you can only use it if you have a radii. And the big circle, I'm not told about a center. Remember, your radius is line from center to circumference. Now, I don't have any line that goes from my center to circumference in the big circle. So as a result, I won't be able to use this. So the only theorem that I'm left with using, it is this one, tan chord theorem. So basically, let me try and identify my Z shape, right? I'm going to just try and use a light green marker. So this, draw my Z to go down like this. So if I could prove that this is equals to that, can you see the Z shape? So basically here, I'm required to prove that if I could prove that my K2 is equals to E2, therefore I would have proven that this line GK is a tangent to the big circle. All right, now let me go about doing that on the other side. So let me see, for my first step, it will be seeing other angles which are equals to this K1. Now another angle that would be equals to K1, remember this is a tangent, and if I were to apply my tan chord, right? I'm trying to identify other angles equals to K1, H4. So H4 is going to be equals to K1, tan chord theorem, right? So let me erase here. I know that H4 is equals to my K1 because of the tan chord, right? So now, what other angle? So, okay, H4 now, can you see that the whole of angle H is an exterior angle of this side quad? Now, let me see if I could equate. I know that this angle H, as a result, H3 and H4, they're going to be equals to this angle E1 plus E2. Now, as a result, I know that my H4 is going to be equals to E1 because I was given that what? I was given that K1 is equals to E1. So I know that my H4 can be equals to E1. Now here, I know that I proved that my H4 is equals to E1. And this H, as I've said, is an exterior angle of a cyclic quad. It's going to be equals to that. Now, if I could prove that this H3 is equals to K2, therefore, H3 is going to be equals to E2. I want you to note something, right? So now I want to see how I can interlink this. This H3, it's in the same segment with K2, right? Can you see the butterfly that is being formed? So I know that my H3 is going to be equals to my angle K2. Why is that? These are angles in the same segment. So as a result, H3 is equals to K2, right? Now, right here, I said H4 is equals to E1, right? Because it was given. Now, H3 is equals to K2. Now, I know that H4 plus H3, they're going to be equals to E1 plus E2. Why is that? As I've said, exterior angle of a cyclic quad. Now, remember, my H4, I said it's going to be equals to E1, right? So these two are equal to one another, right? My H4 is going to be equals to E1, meaning that H3 is going to be equals to E2. H3 is going to be equals to E2, right? Because of that, right? And remember here, I'm trying to prove that my E2 is equals to my K2. And remember here, I've said before that H3 and K2 are equal to one another. And I can conclude that in this instance, my K2 is going to be equals to angle E2, right? Why is that? It's because my H3 is equals to K2. Before I've proved that my H3 is equals to K2, all right? So now, as a result, I can substitute K2 where there is H3. Now I've proved that this K2 is equals to E2, right? I've proved my Z shape, right? So now let me try and erase everything here so that you could see what I mean. And I'm saying I've proved that K2 is equals to E2, right? Which is your Z shape, your tan chord. Therefore, you can conclude that GK, right? Therefore, GK is going to be a tangent. And why is that? Tan chord theorem.